Hello students. Last class we solved one numerical on phone clutch. So this is a problem. Bit of elaborate data was given. So we finished this problem I think quite with ease. It was over pretty soon. There is one more numerical on phone clutches, and this will be the last numerical on phone clutches. Suppose this numerical will start off with the next topic, which is brakes, right? Right. Check out this problem. We need to design a cone clutch whose face is lined with woven asbestos and which needs to transmit 9 kilowatt power. So woven asbestos and material of shard is steel. Right. We'll note down the data one by one. This is the second numerical. Numerical number 2. Data given is woven asbestos there is a combination of material given. There is woven asbestos is coupled with steel. Okay, that's how it will be. So it needs to transmit a power of 9 kilowatt. So let's note down that too. The power transmitted is 9 kilowatt and at 600 rpm. At N is 600 rpm, and the mean diameter of the friction lining is 270 mm. So this data is different from the previous numerical. So in the previous problem we had to find the mean diameter, but in this one the mean diameter is given. So therefore this is a type 2. There are two types of problems when it comes to cone clutches. One which mean diameter is not given, and another one which is given. Since this is given, this problem is even more simpler than the first type. Let's note this down. So mean diameter means dm is 270 mm. That's it. Material shaft and permissible shear stresses. So tau permissible. This data is useful when we are finding the diameter of a shaft. That is. So permissible shear stress is 65.7 megapascal. Right. That's all data which is given. Let's move on to the solution part. The problems in brakes and clutches, they are small and they're simple. So majority it may be asked for 10 marks. So gears which we did in previous model, that is the largest module of problems you will encounter. So all these problems are pretty simple, what we can say. Okay, let's check out the steps from the presentation. Right. So type 1, type 2, only one small difference is there. As I told you while presenting, I have input the notes somewhere here. All right, see, check it out. For type 2, mean diameter will be given. Then just skip step 3 and follow all other steps. So that's only the simple change we need to make. Only skip the step 3 as we already know the mean diameter. Okay, so let's proceed with the steps. Okay, check it out. Step one. Step one is as seen, it is torque to be transmitted. Torque to be transmitted. So that is given by P equal to 2 pi n T over 60,000. Okay, 2 pi n T over 60,000. This will be in kilowatts. Okay, so we already know the power is given 9 kilowatt. Right, so we'll just note down 9 equal to 2 pi into n, which is 600 times T. So you can use MT or T. Both work the same way. And this is 60,000. Okay, so simplifying this, we'll get the torque. MT or T is torque transmitted. This will be in terms of Newton and this is just check this out. If you're calculating, you can calculate and let me know the solution. Okay, let's move on. So this is let's move on. Step two. Step two is diameter of shaft. You can see the PPT. At step two, you need to find diameter of shaft. So if this material for shaft is not given or the permissible stress for the shaft is not given, then you can skip this step also, as we did in the plate clutches. Right. So step two is diameter of shaft. And we can find this equation, which is D equal to cube root of 16T over pi tau permissible. So this can be found in any data book, but I prefer you memorize this. So this is again cube root of 16 times torque. Anybody found torque? So 9 times 60,000 over 2 pi and 600 is giving me 143.24. That is in Newton meters. So I'll be getting 14329. 14329. So if you got the same answer, so this is 14329. So that much. 1432. Oh, no, sorry. 14323 14329. This is in Newton mm. Let's use that here. 14329 0.239 under the root over 5 into tau permissible. That is given in the data 65.7. Let's use that 65.7. So from this you will get the diameter D. Okay. So try finding out the diameter. In the meantime, we'll go back to the presentation. So this is step 2. So step 3, since we don't need this, let's skip this part. Okay, entirely skip, not even take the one single portion of it. And what will happen here is we'll find in terms of B here. So some of the other dimension will be empirically found. That is. So step 3 in the presentation will be skipped. So step 4 becomes step 3 now. So axial force. So let's note this down. So next step 3 is axial force. Axial force. So FA is pi dm b in small p sine alpha. So this is given under equation 13.10. 13.10c. Okay, so here we know dm, right? With dm is given in the question. You can see here is 270. So this is 270 mm. Then b, we'll write this equation in terms of b itself, and then p. So p is nothing but p max. Right? So p. So for this we need to refer to the data handbook. Let's go back to the PPT. So check it out. P here will be from table 13.4 for a given material type. So this is where you get your P from. And what was the data? Woven asbestos. Woven asbestos with steel. Woven asbestos with steel. Woven asbestos is the friction material. So this whole thing here is a friction material. So this entire thing is the friction material, and let's see. Let's check out the data handbook for this. A combination of woven asbestos with steel. So again, there are two different variable values. You can choose either wet or dry kind of friction. Okay, then that depends. So for this, let's just assume this dry itself. So because the fluxes, I think they're used in a fluid kind of environment. So most of the time we assume the dry portion here. For in case of clutches and gas, no? Since it's woven asbestos mating with the steel or touching with the steel, we'll use this entire uh, dry area for this. So let's choose this. So coefficient of friction 0.32, 0.6, and pressure 0.34 to 0.69. Okay, let's get back. The pressure is 0.34 to 0.69. So we'll just take an average of this. Take an average of this and then substitute. Alpha is the angle, okay, that half cone angle which we referred. In the meantime, we'll note down this value of mu also, 0.3 to 0.66. Mu is 0.3, yeah, just 3 to 0.6. Again, we'll take an average of that. And both of these data came from table 13, okay, for the material, that is woven asbestos and steel combination, and considering dry condition. Okay. Let's take an average of this. So 0.34, 0.69 over 2 will give me 0.515. And for alpha, no, alpha is given just below the equation. Check it out here. So alpha is 12.5 for cone clutches faced with leather, and this is faced with wood. Okay, so for here, what we can take is can equate asbestos equal to wood. Can take anywhere between 15 to 25 degrees, or in between. Let's say we'll take alpha as 20 degrees. So for only for when it's specific for leather, then we'll take this, or if it's asbestos or any other material, we'll take in anywhere in between these values, 15 degree and 25 degrees. So let's take 20 degrees here. I'm just assuming alpha 20 degrees. So, and mu will be halfway between 0.45. Okay, so now we have all the data required for the FA, that is in terms of B, that is the face width. Let's find out. This is FA is equal to 5 times dm 270 times B times pressure 0.515 into sine 20 degrees. Okay, so now this value of FA will be in terms of B. Let's find out what it is. So in the meantime, anybody found out diameter? 16 times 143239 divided by pi times 65.7, and this is cube root of answer. Okay, so I'm getting 20. I'm getting 22.31. Now approximate this to, let's say, 24 mm. So let's keep it an even number. That's about D. About this, 0.2270 into 0.515 to sine 20. Okay, so FA I'm getting 149 point say 4 B. So this is FA. Right, that's it. That's about the axial force. Move on to next step. Step 5 is torque transmission capacity. In the first step, we found out torque required to be transmitted. So this is torque capacity. So step 4 is torque transmission capacity. Right. So this is given by T or MT is equal to mu FA and dm over 2 sine alpha, and this is given equation 1310d. 13.10d. Okay. So one by one again, mu we already found out the value, which is 0.45. This we would have got from the table. Okay. FA is in terms, it's here itself, so it is in 149.4b. Then dm given in the data 270. Then alpha also known 20 degrees. So what we can find here is the dimensions again. Okay, this also will be in terms of b, and we'll equate with respect to the torque in step 1. Let's check it out. Torque T is mu is 0.45 times FA, 149.4 B into dm 270 whole divided by 2 into sine 20 degrees. Okay, so this torque capacity will be in terms of the phase width B. Let's find out. 0.45 times 149.4 times 270 over 2 sine 2 into sine 20. So this we have got around so this torque I've got around 2 6 26536.6 yeah 0.6 B. Let's check this out. Okay, this also will be in terms of B. Okay, so this is not 6, please note. Okay, this here, let me just write it in a different color for you. So this here is B, it is not 6. Okay, so this is the B which we have got from here itself, in the right from the formula. Okay, so this B here is still as it is. This is not 6. Okay, some might be confused and you are posting the answers with others considering B, I guess. Okay, that's B, not uh, 6. Okay. Okay, this is B, not 6. Right. So we'll move on to the last step. Step 5. So this is just equating. You check out the steps now. So the last step is just equate torque transmitted and the torque transmission capacity, the required and capacity is just equate. This is torque transmitted capacity. This is one we got from step 5 equal to, this is from the step 1. So capacity what we got 2653.6 and this is B is equal to torque transmitted. This will take it from step 1. Step 1 is 143,239. This is 143,239. So with this we'll get what is the value of B here. So B is nothing but phase width. Okay, just find out and tell me the value. See. So after finding this we'll find the axial force required. So that there's one value is required to be found. So FA we got around 149.4. This is 149.4. Again, this was B. B and two more dimensions. From here, D1 is dm minus b sine alpha. D1 is the outer diameter of the cone. Dm minus, oh sorry, inner diameter b sine alpha, which is what is that 270? Dm 270, right? 270 minus b. So anybody found b? Just let me know. 143239 divided by 26536.6. So I'm getting face width as 5.4 mm. Let's use the same thing. So 5.4 into 149.4 is you get axial force required to engage this particular clutch, 806.43 newtons. And similarly here, make 5.4 sine alpha, or alpha is already assumed this as 20 degrees. Let's see how much the diameter goes for. 270 minus 5.4 sine 20. Right, so this is 268.15 mm, and D2 is the outer diameter of the cone, that is given by dm plus v sine alpha. You just have to introduce plus in your calculators, so that will come to 271.85. Okay, so these two diameters you can just imagine. So if you want to draw a small figure, and you can represent that. So let's say this is the cone clutch. To work on these drawing skills, the tab, Okay, so this here is B. So this is called the face of the cone. So this is a cylindrical body here. So in this cylindrical body, this accounts for the face would be, and this here is D1. Let me just change the color for dimension. Okay, this here is the D1, and this dimension here, the outer one, is D2. So these are all the key dimensions which are required for the, yeah, this is D2, and DM is the mean, somewhere in between here, the mean diameter of cone. So this is what was given initially in the question. This is DM, right? So these are all the key dimensions. We then have D1, D2, and DM. That's it. Right. So any doubts you have, let me know in the group chat.